I'm back! I'm back!
Good morning, geometry. We're going to start chapter 6 and see what we can do today, okay? So chapter 6 is called Angles of Polygons, and we did a bunch of triangles in our last chapter, and now we're going to start on some other different things, mostly quadrilaterals. So let's first talk about what a diagonal is, okay? A diagonal is from one vertex to another, and, well, let me just show you. I obviously can't go from that vertex to that vertex because that would just be the side, right? So if I go from that vertex to that vertex, that's a diagonal. Of course, on this one, I also could go this way. And as we get more complicated, there's more and more diagonals. Let's make a little chart here because we're going to try to figure out the interior angles of these quadrilaterals, and there's a little pattern that goes on here. So let's start with just a simple triangle. We've got three sides. I can't draw any diagonals. Does that make sense? So the number of triangles that I get here when I draw diagonals is I get one triangle. And of course, you know that when you add up the angles inside, the interior angles, it's 180 degrees. Or I can say 1 times 180, and you'll see why I did that in just a second. If we go to a quadrilateral, now I showed you that I can go from this diagonal to, or this vertex to this vertex and that to that, but if I just go from one corner, one vertex, I can only go to one other vertex, and that chops this into two triangles. Does that make sense? So we got four sides, two triangles, and now I'm going to get 2 times 180 degrees. Some of you are already catching on to the pattern. If I go to 5, it's a bad 5, but let's go from this one, and we're just going to go to as many vertices as we can go to. So 1, 2, and we can't go to that one, so that's it. But do you see, so sorry, this is 5 sides, but do you see now that we've chopped this into 3 triangles, so it's going to be 3 times 180 degrees. I'll push my luck and try for 6. Can you see that? Oops, sorry. If I was a honeybee, I could do this a little better, but okay. So 1, 2, 3. So when we have 6 sides, I can chop this into 1, 2, 3, 4 triangles. So it's going to be 4 times 180 degrees. And the pattern just continues. So what I really want is I want some kind of general formula. So if you look here, the number of sides is related to this. 3, we're going to get 1 times 180. 4, we're going to get 2 times 180. 5, 3 times. And so you can always see that this is 2 less than the number of sides. So the general formula for interior angles of any polygon is, let's call an n-gon is going to have n minus 2 times 180 degrees. So if I had something with 50 sides, you're going to have how many degrees? Quick, quick! Of course, it's going to be 48 times 180 degrees. Okay? And I believe that they give that a number. That is theorem 6.1. Put that in the old hopper. 6.1 is this way to figure out how many degrees in the interior angles. Okay, now I got to erase all this. I'll see if I can not knock it all down. Second thing, if I had, let me do something, okay? So if I had a pentagon, and if I carry these on, do you remember these things are called exterior angles, okay? And so, sorry, let me reach around you and turn the page because I can't remember what page it's on. But if you go a couple pages here, it is... Sorry. Oh, there it is at the bottom. It's hiding behind the computer screen. It's on page 426. If you go to page 426, theorem 6.2 is the exterior angles sum theorem. And it just basically says, no matter what kind of polygon you have, now it might not look like it at the beginning, but if you add up all these exterior angles, it adds up to 360 degrees. Crazy. So if you had a triangle, carry that on, carry that on, carry that on, boom, 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 360 degrees. This one you can see, think of this as a square. I know my drawing's bad, but you can kind of see that this is going to be 90 degrees, this is going to be 90 degrees, this is going to be 90 degrees, and this is going to be 90 degrees. So you can see that one a little bit better. But it doesn't really matter. No matter what polygon you have, theorem 6.2 says that the sum of the exterior angle measures of a convex polygon, one angle at each vertex. So yeah, so you're not measuring both things. You're not measuring both. You're measuring one or the other. But when you do that, it's going to be 360 degrees. Okay? All right, theorem 6.2. That's all for this introductory section. And I am about to go play some golf. All right, see ya.